Inshallah, in today class, we are going to start a new chapter, beta gamma functions. Beta gamma functions. Sometimes this is also called as special functions. Special functions or improper functions. So let we have the formulas and little concept of beta gamma functions. These are also called as special functions or improper functions. Now let me start with the definition of beta function. Beta function is nothing but the integration, this integration 0 to 1 x power m minus 1 into 1 minus x power n minus 1. This integration is called beta of m comma n. So this is the definition. Beta of m comma n is 0 to 1 x power m minus 1 into 1 minus x power n minus 1. This is the definition of the beta function. This integration is termed as beta gamma, beta of m comma n. Now the second formula is beta of m comma n equals to beta of n comma n. That means this is interchangeable. That means beta of 4 by 4 comma 3 is equal to beta of 3 comma 4. We can interchange. The value will remains the same. Value will remains the same. This is the second concept. And when we have to change beta and gamma in terms of sine cos, we have to use this formula. Beta of m comma n equals to integration 2 into integration 0 to pi by 2 sine power 2m minus 1 theta into cos power 2n minus 1 theta d theta. When relation between beta and sine cos functions, or generally we use this formula. One more formula is there, 0 to pi by 2, same we can change to this one. Sine power m theta cos power n theta d theta equals to 1 by 2 into beta of m plus 1 by 2 comma n plus 1. When we see that the question is in terms of sine or cos or sine cos or tan or cot, we have to use this formula. We have to use this formula. And lastly, in this formula there is only one or two questions based on this formula. When we see 0 to infinity and in denominator 1 plus x, we have to use this formula. When we see 0 to infinity or 0 to some term and denominator is 1 plus x, we have to use this formula. Beta of m comma n equals to integration 0 to infinity x power m minus 1 divided by 1 plus x plus 1. Now in the same way, let we have a few formulas of gamma functions. Now gamma of n, this is the definition of gamma function. This improper integration is called gamma function. This improper integration. What is improper integration? Integration 0 to infinity x power n minus 1 into e power minus x is defined as gamma of n. Is defined as gamma of n. 0 to infinity x power n minus 1 e power minus x dx. Now relation, this is very important formula. We have to use in generally in many questions we have to use this formula. Relation between beta gamma function. Beta and gamma relations. Beta of m comma n equals to beta gamma of m into gamma of n by gamma of m plus n. Gamma of m into gamma of n by gamma of m plus n. One more formula is here. This formula generally sometimes we have to use. I will explain the questions when we are going to use this formula. In questions I will explain this formula. Gamma of n into gamma of 1 minus n equals to pi by sin n pi. Pi by sin n pi. Now lastly, gamma of 1, the value of gamma of 1 is 1. The value of gamma of half is always root pi. The gamma value of gamma of half is root pi and gamma of 1 is n. We have to let me see some more values of gammas, how to find the values of gamma of function. Now see here some more values. Gamma of n, actually we use the formula n minus 1 gamma of n minus 1. Gamma of n equals to n minus 1 gamma of. This generally we use when the value of n is in fractions. The value of n is fractions other than by 2. I'll explain. Suppose gamma equals to 3 by 4, gamma equals to 7 by 3, like these factors. 7 by 3, not by 2. For by 2 we are having here for this formulas other than by 2, by 4, by 3, by 5, whatever. When we have the value of gamma in terms of fractions, let me use this formula n minus 1 gamma of n minus 1. And if the value of n is integer, the gamma of n is n minus 1 factorial. If n is integer, the formula of n is gamma of n is n minus 1. For instance, suppose gamma equals to integer 7, 10, 15. So gamma of 7 will be 7 minus 1, 6 factorial. Gamma of 10 will be 10 minus 1, 9 factorial. Gamma of 15 will be 15 minus 1, 14 factorial. For integers, this is formula. For fractions other than half, by 2, this formulas. If you get by 2, you practice directly like this. Suppose you get 11 by 2. When we get denominator 2, we have to use this formulas. When we have denominator 2, we have to use this formulas. You see here we are having 11. So reduce this by 2, 7. Sorry, 11 reduced by 2 means 9. 9 by 2. Again reduce by 2, 7 by 2, 5 by 2, 3 by 2. Last you will get 1 by 2. Into you have to write root pi. You practice this one. Suppose some gamma of 5 by 2. Start reduce by 2. This will be 3 by 2. Again reduce by 2, 1 by 2. After last 1 by 2, we have to write root pi. For instance, we are having gamma of 7 by 2. How to start? Reduce by 2, 5 by 2. Again reduce by 2, 3 by 2. Again reduce by 2, 1 by 2 into root pi. And similarly, gamma of 3 by 2, reduce by 2, 1 by 2. After 1 by 2, we have to write root pi. And lastly, if we are having the value of gamma negative, the value of gamma negative, then we have to use this formula. Gamma of n equals to n, gamma of n plus 1 by n. Gamma of n equals. So suppose we are having value in terms of minus 5 or minus 7 by 2, whatever the value, if the value of gamma n is negative, we have to use this formula. Gamma of n equals to gamma of n plus 1 by gamma. So I request you students, first you recall all the formulas, you paperize this, write on a paper, and you first practice the formulas, because if you know the formulas, it will be easier to do the problems. So I request first you write all the formulas, paperized all the formulas, you by heart this. Now let me do the questions based on this formulas. These are called special functions and beta gamma functions. We'll do the questions on this section. And also the proofs of this will be done after the solving the questions. I am going to first complete the questions, numerical problems. After that, the proofs are very important of this chapter. Proofs of these formulas are important. So I am going to cover that at the last of the chapter. Now see here, there are three questions on the board. The first one is integration 0 to 1, 1 divided by under root of 1 minus x power 4. We have to show this value, this one. And the second and third question. Let I do the first one and third one. You try the second one by yourself. Okay. So let me start with the first question. So see here, what is the first question? Integration 0 to 1, 1 divided by under root of 1 minus x power 4 dx. See here, how to find how to understand that this question is based on. See here, whenever we get 1 minus x or something like this, understand that we have to change this into beta function. We have to change this into beta function. So what is the value of beta function? We already discussed, just now discuss. The formula of beta function is 0 to 1, x power m minus 1, 1 minus x power n minus 1 dx. This is the formula of beta function. So we have to change this until we get like this, so let me start. First you do one thing, take out the root. If you take out the root, you will get like this: 1 divided by 1 minus x power 4 whole power 1 by 2 dx. Now the next step is bring this in the numerator. The power plus half will become minus half. If you bring the denominator from denominator to numerator, this value, this power will become minus 0 to 1, 1 minus x power 4 power 1 by 2 dx. Now always for this type of questions, you see here, what is here? 1 minus x. This x doesn't have any power. This x doesn't have any power. But if you see here, we are having power 4. So to take out this power 4, we should have 1 minus x, not 1 minus x power something. For that reason, we have to suppose this x power 4 equals to some other variable, suppose y. So this is the method, always put x power, whatever here, we have to suppose this as y. So bring this 4 here, it will be 1 by 4. So x equals to y power 1 by 4, y power 1 by 4. If we bring this power from here to here, it will become 4 will become 1 by 4. Now let you differentiate both sides. The differentiation of x will be dx. The differentiation of x will be dx. Dx equals to, now d by dx of x power n, we know d by dx of x power n is n into x power n minus 1 dy. One more step, dx equals to 1 by 4 into y power. Now I take LCM, 4 ones of 4. 1 minus 4 will be minus 3 by 4 dy. So we got the value of, in place of dx we can write this, in place of x we can write this, in place of x power 4 we can write this. Watch here, Now here you see here the limits will not change. Sometimes limits changes, but here if you put the value of x 0, here 0, you will get y also 0, 0 power 4 will be 0. So lower limit will remain the same. In the same way, if the upper limit we substitute x equals to 1, 1 power 4 will be 1. So there will be no change in the limits. Some if limits changes, we have to show how the limits also changing. But in this question, there is no change in the limits. When we keep x 0, y also 0. When we keep x1, y also 1, so there is no change in the limits. So I am continuing here, equals to, you see here integration, no change in the limits, 0 to 1. See here 1 minus x power 4, the value of x power 4 is y power, sorry, if you bring this in the numerator it will be minus of, so minus of into dx. We got this value as dx, we got this value as dx. Now watch carefully, this is constant, so we can write constant outside. Always write the constant outside. What is left here? Y power minus 3 by 4 dy. So just I am writing like this, 1 by 4 into integration 0 to 1. I am writing first y. Y power minus 3 by 4 into 1 minus y power minus 1 by 2 dy. Now if you observe here, what is the difference between this and the formula? Same, you see, we got in place of y x, we got x. Here's the formula, in place of y we got x, 1 minus x, 1 minus y, same. The only difference is that the last step we have to get the power, we must have minus 1, m minus 1, n minus 1, m minus 1, n minus 1. So to bring minus 1 in the power, let me do the rough work. You see, we are having minus 3 by 4. We must have in power minus 1. To get minus 1, we have to add and subtract 1. We have to add and subtract 1. To get here minus 1, we have to add and subtract 1. Now you add this two terms, 4 ones are 4. 4 minus 3 is 1 by 4. 1 by 4 minus 1. So with this power we can write like this, 1 by 4 integration 0 to 1 y power minus 3 by 4 can be written as 1 by 4 minus 1. 1 by 4 minus 1 into 1 minus y power. In the same way this one, we must have in power minus 1 to change into the formula. To get minus 1, we add 1, we subtract 1. Now you add these two terms, remain this as it is, 2 ones are 2, 2 minus 1, 1 by 2 minus 1. So we can write this 1 by 2 minus 1 dy. Now you see this is exact of the formula, x power m minus 1, 1 minus x power n minus 1. So this is the formula of beta function, beta of m comma n. In place of m we are having 1 by 4, in place of n we are having 1 by 2. So always remember, when we get the formula of beta, we have to change into gamma. Always whenever we get the formula of beta, then we must change into gamma. So we know what is the change, what is the relation between beta and gamma? Gamma of m into gamma of n by gamma of n plus. So in many questions after, when we get the answer in beta terms, always the next step we have to change into gamma. So what is the relation between beta and gamma? Beta of m comma n is gamma of m into gamma of n divided by gamma of 1 by 4 plus 1 by 2. Now the last step, gamma of half is root pi. Gamma of half is root pi. So this we can write as root pi. Okay. So I am writing this as it is, 1 by 4. 1 by 4. Okay. You see here, gamma of half is root pi into, sorry, gamma of half is root pi into 1 by 4. This 4 I am writing here into gamma of, if you take add this one, half plus 1 by 4 will be 3 by 4. We take LCM 4, 1 plus 2, 3 by 4. So gamma of 3 by 4. So this is the answer we have to, this is the answer we have to change to this answer. What is the answer? Gamma of half into gamma of, okay. So you practice this one. Let me do one more question. Okay. Just now we have done the question. No, the question is written wrong. Here we are having 4. Okay. Now let me do the third question. Let me do the third question. What is the third question here? Integration 0 to 3, 1 divided by under root of 9 minus x square dx. Now watch carefully. Let me take out the root. If we take out the root, it will be half. If you bring in the numerator, it will be minus half. So we can write like this, integration 0 to 3, 9 minus x square power minus half dx. Now I just explained, we have to change this to the beta function definition. So what is the definition of beta function? Beta of m comma n equals to integration 0 to 1 x power m minus 1 into 1 minus x power n minus 1 dx. Now watch carefully. We have to change like this: 1 minus x, 1 minus x. Here is 9. We have to take out 9. If here also we are having 9, we can take 9 common. If we take 9 common, it will become 1 minus something. Therefore, let we start like this. Put x square equals to 9 into y, because we doesn't want the power here, we don't have any power here. Therefore, we suppose x square equals to 9y. If you take out root square, it will be root here. So x equals to root of 9y. We know root of 9 is 3. So therefore, x equals to 3 into y power 1 by 2. The value of x is 3 into y power 1 by 2. Now let me do one thing. Let me integrate both sides, differentiate both sides. X will be dx. In differentiation of x is dx. 3 into, no, this is d by dx of x power n. D by dx of x power n is n into x power n minus 1 y. So lastly, what is here? Dx equals to 3 by 2 y power 2 ones are 2. 2 minus 1 will be minus 1 by 2. So this will become y power minus 1 by 2 dy. Now let me change the question. In place of x square, we keep 9y. If we get x, we have to suppose 3 into y power 1 by 2. And dx is this. Also see here, the limits will change. Now I will explain you. You bring this 9 here. So what will be the value of y? Y equals to x square by 9. Y equals to x square by 9. What is the lower limit? 0. So suppose x equals to 0. You suppose x equals to 0. Y equals to 0 square by 9. That is 0 only. Now if you suppose put x equals to, upper limit is 3. Put x equals to 3. If we put here x equals to 3, we'll get the value of y. That is the upper limit. When we put x equals to 0, lower limit, the value of 0 y will be lower limit. If we put x equals to 3, then y will be equals to y equals to 3 square by 9. That is 1. So you see here limits are changed. You want to show, you can show like this. Suppose x, y. When we keep x 0, we get y also 0. But if we keep x equals to 3, we get y equals to 1. So previously lower limit was this, upper limit was this. But now the lower limit is this and upper limit is 1. So the limits are also changed here, 0 to 1. So let me continue this one. Integration of, in place of 0 to 3, we keep 0 to 1. 0 to 1. 9 minus, here we are having x square. But the value of x square is 9y. So this is 9y. Value of x square is 9y. Power minus 1 by 2 into dx. The value of dx is 3 by 2 is constant. Keep it outside. 3 by 2 into this one. Y power minus 1 by 2 dy. Now let me solve this until we get the value of beta. Then we have to change it to gamma. So next step you see here, this is 3 by 2 as it is. Integration 0 to 1. Let me take 9 common. If we take 9 common, what is left here? 1 minus y. But this power we have to write both with 9 and this one. 1 minus 1 by 2 minus 1 by 2 into y power minus 1 by 2 dy. Now you think 9 can be written as 3 square. Bring this outside. I'm writing here. You see here. Equals to 3 by 2 into 9 can be written as 3 square power minus 1 by 2. 3 by 2. 9 is 3 square power minus 1 by 2. Integration 0 to 1. Y power minus half into 1 minus y power minus half dy. So next step is here. This 2 will get cancelled. 3 power 1 into 3 power minus 1 is 1 by 3. 3 will get cancelled. The value will be 1 by 2. 3 power minus 1 is nothing but 1 by 3. 3 will get cancelled. Or you can say like this, powers will be added. 1 minus 1 0. 3 power 0 will be 1. Integration 0 to 1. Now we have to bring here minus 1. Here also minus 1 to change into the formula. So minus 1 how to get? Add 1, subtract 1. 2 ones are 2. 2 minus 1. 1 by 2 minus 1. So this will become y power 1 by 2 minus 1. 1 minus y power 1 by 2 minus 1 dy. Now we got this into, let me change into beta. So beta of m comma, that is half comma half. After changing into beta, we have to change into gamma. So we already know what is the formula of gamma. Half into beta, we have to change into gamma. Gamma of m into gamma of n divided by gamma of m plus n. Now only two steps are left. 1 by 2 into gamma of half is root pi. Gamma of half is root pi. This is half plus of 1. Gamma of 1 is 1. So last step, root pi into root pi will be pi. Root pi into root pi will be pi divided by 2. Now let me do the last question in this part. So I am starting this one. First bring this in the numerator. The plus 1 by n will become minus 1 by n. Plus 1 by n become minus 1 by n. So it will be like this. Integration 0 to 1. 1 minus x power n whole power minus 1 by n dx. From here we have to continue. From now we have to put this one as y. X power n as y. X power n as y. I'm writing here. Put x power n equals to y. So the value of x will be y power 1 by n. Now you differentiate this one, x will become dx. D by dx of x power n is n into x power n minus 1. This is dy. So let me change the question. In place of x power n, we can write y. In place of dx, we can write like this. And there's no change in the limits. You see here, if you put 0, 0 power n will be 0. So y will be 0. If you picked 1, 1 power n will be 1. So there is no change in the limits. See, I'm changing the question. Limits as it is 0 to 1. Watch carefully. 1 minus x power n, we are having y. Whole power minus 1 by n dx. Dx, we are having this one. You put 1 by n outside. What is left here? Y power 1 by n, n by 1 by n minus 1. Now see here, you first write this one. 1 by n integration 0 to 1. Y power 1 by n minus 1. 1 minus y power minus 1 by n. You see here, to bring into the formula, we are already having here minus 1. We are already having minus 1. Here we don't have minus 1. To bring here minus 1, we write plus 1 and minus 1. We write plus 1 and minus 1. Plus 1 and minus 1. So let me change this one. Equals to 1 by n into, this will be beta x power n minus 1 into 1 minus x power n minus 1 is beta of m comma n. So beta of, in place of m, we are having 1 by n. In place of n, you write first one, this 1 minus 1 by n. Plus term first and minus. After changing into beta, we know we have to change into gamma. We have to change into gamma. So this will be 1 by n into gamma of n into gamma of n divided by gamma of n plus n. So this plus 1 by plus of minus plus 1 by n minus 1 by get cancelled. What is left here? 1 by n into gamma of 1 by n into gamma of 1 minus 1 by n. Watch here, we wrote one formula like this. Gamma of n into gamma of 1 minus n. You see in the starting we wrote a formula like this. Gamma of n into gamma of 1 minus n is pi by sine n pi. Pi by sine n pi. So let me change this one. Equals to 1 by n into 1 by n to pi by sine n pi. In place of n, we are having 1 by n. So 1 by n pi. The last step, we can write like this. Pi by n. Pi by n. If you bring this sign, the numerator will become cosec. Cosec pi by n. So we have done few questions based on the beta functions. Inshallah, in the next part, we will continue with the same method, beta, then continuing with the sine cos questions in the inshallah next part. Okay. So I request you all students to like this and share this and subscribe my channel. Inshallah, I am going to continue the same methods in the next part. Inshallah.